another section. On this video, we'll be discussing 5 basic concepts of probability. So the first question you should ask yourself is, what is probability? According to Oxford Dictionary of Economics by John Black, probability is defined as the likelihood that an event will occur. Every probability lies between 0 and 1. 0 in the sense that probability is a negative probability and has no chance of occurring. But when it's equal to 1, it's a positive probability and has possible chance of occurring. In the course of living, in our day-to-day activities, we all participate in probability without even knowing. Like, for example, before preparing a meal, you have to make sure that the necessary ingredients of preparing that meal are available. Even if they are not available, you have the resources to afford those ingredients to prepare that meal. But in a situation whereby you want to prepare a meal, but the ingredients to prepare those meals are not available and you don't have the resources to afford those meals, then it's a negative probability. Then it means the probability is equal to 0. So there are methods that we can use to predict or ascertain probability. The first method is the past experience, and the other method is the theoretical method. Let me write them down. Yeah. We have the past experience. The theoretical method. Now let's make an example of this past experience. Okay, with this statement, what is the probability that John will make it early for statistics class tomorrow? Now, if John is someone that usually comes late for statistics class, then it's easy to predict that he will come late again for the next class. So you can use past experience to predict or ascertain probability. Now, using the theoretical method, let's assume this question says, what is the probability that 10,000 will last John for a month? Now, John will be given 10,000 as allowance. And in a month, we have 30 to 31 days, right? 30 to 31 days in a month. Now, using the theoretical method, you will look at John, you study John. How much does John spend a day? Let's assume John spends 1,000 naira daily. By the time you divide 10,000 by 1,000, it will be 10 days. So the probability that 10,000 will last John for a month is negative. So it's equal to 0. That means 10,000 cannot last John a month. That is using theoretical method. Now we've been able to predict. Even though John is still spending around 10,000 naira, we know already that 10,000 naira will not be enough for John in a month. So the 5 basic concepts of probability. We have number 1 is event, experiment, sample space, outcome, and probability itself. Now I'm going to be explaining them one after the other, starting with events. So an event is a collection of possible outcomes from a probability experiment. Now let's say, for example, a coin is being tossed. Now a coin has head and tail. When it's being thrown, either we get a head or a tail. Now these are 2 events occurring. One of them will occur. So events is the collection of possible outcomes. It's either we arrive at head or we arrive at tail when the coin is being thrown. But whichever one we arrive at, the both of them are events. One of them will occur. So this is what event is. And event is denoted by a capital letter E, like this. Now, to the next one, experiment. Now, in probability, experiment is a process that can be predicted in which the result is uncertain. The result has not yet been concluded, so the probability can still be predicted. Like, for example, let's take a football match, for instance. We have two clubs, Club A and Club B. Let's say you have a bet to someone that Club A will score the first goal. Now, the match has started, but neither of these teams have scored the goal yet. But looking at the performance of each club on the field, or maybe through their past experience, you may be able to predict that Group A will score the first goal. Though the experiment is still going on, no team has scored yet. But as far as the experiment is still going on, the result is uncertain until one of these teams score the goal. So until the result is certain, you can still predict the experiment. So experiment is basically the process of probability. Without experiment is very essential in probability. Experiment is the whole body of probability. It's from the experiment that we ascertain our answer or get our result from. Or for example, you have been asked what the probability of getting a head from throwing a coin. Now, the process of throwing that coin may still be going on, but the result isn't out yet. So experiment is the process of probability. Experiment is basically probability in action. So as far as probability is still in action, the results or the outcome hasn't been gotten yet. So you can still predict until the outcome are available. And we have outcome as number 3. So outcome is basically the result of an experiment. Outcome is the answer of probability. Now let's move on to sample spacing. So sample space is the collection of all possible outcome in an experiment. All possible outcome can also be referred to as sample points. Let's say the experiment is about tossing a die and arriving at a 3. Our sample space will be equal to all the possible outcomes. So we have 1, 2, 3, 4, 5, and 6. These are all the possible outcomes of throwing a dice. So these are our sample space. Now, the sum of a sample space will always be equal to 1. Note that. Let me write this one here. The sum of sample space of any given probability will always be equal to 1. This is very important. You need to note it. The sum of sample space of any given probability will always be equal to 1. So let me explain this statement. The probability of sample space is equal to sum of expected outcome. Sum of expected outcome ratio total outcome. Now, looking at this, our total outcome, let's use this. Our total outcome here is 6. 1, 2, 3, 4, 5, 6. Remember, we're not using the value here 1, 2, 3, 4, 5, and 6. The value written does not matter in probability because these are the faces of the dice. In probability, each of these sample space has 1 unit. 1 has 1 unit, 2 is representing 1 unit. Each of them are representing just themselves with 1, 1, 1 unit. So now, the total outcome is equal to 6. Okay, let me put that here. Our total outcome is equal to 6. And our expected outcome is 1. Because we are only expecting the die to give us one of these results. A die cannot show us 1 and 2 at the same time, except we throw the 2 dice at the same time. But as far as it's just what we are solving for now is just 1 die being thrown at once, it will give us just 1 outcome. So now the sum of expected outcome ratio total outcome. Now bring in each expected outcome. We have 1 ratio total outcome is 6. The sum, so you add it. We have another 1 here. 1 ratio 6 plus 1 ratio 6 plus 1 ratio 6. 1, 2, 3, 4, 5, 6. So our total outcome is 6, but the sum of our expected outcome is represented in this way. So the next step you will do here is to bring your LCM down and then multiply through by your LCM. Let me create this space for that. So our LCM here is 6. We have 6 as our LCM. 6 divided by 6 is 1. 1 times 1 will give us 1 plus 6 divided by 6 is still 1. 1 times 1 will give us 1. So that plus 1 plus 1. 1, 2, 3, 4 plus 1 plus 1, 6. 1, 2, 3, 4, 5, 6. By the time you sum up everything here, you will arrive at 6 and your denominator is still 6. 6 divided by 6 is 1. So now you understand this statement which says the sum of sample space of any given probability will always be equal to 1. No matter how much the probability is. Assuming this die is being tossed twice, the sum will still be equal to 1. Let's assume it's a coin that is being thrown this time, and a coin has 2 faces. If you throw a coin, you either arrive at a head or a tail. That if you throw the coin once, if you throw it once, you either arrive at a head or a tail. Now, each of these sample spaces are having 1 unit each. So our total outcome is 2. Now our expected outcome is 1 because we are expecting just one result, either 1 head or 1 tail. So now our probability for sample space is equal to 1 over 2 plus 1 plus 1 over 2. Our LCM here is 2. 2 divided by 2 is 1. 1 times 1, 1. Plus 2 divided by 2 is 1. 1 times 1 is still 1. Sorry. 1 times 1 is 1. Equal to 2 over 2. Now, 2 divided by 2 is equal to 1. The sum of sample space of any given probability will always be equal to 1. Now, let's make it double. Let's try another example. Let's assume instead of the coin being thrown once, let's assume the coin was thrown twice. That is, if the coin is thrown twice, it's going to give us double results. So if the coin is being thrown twice, our sample space will have head, head, or we have head, tail, or we have tail, tail, or we have tail, head. These are the possible outcomes if the coin is thrown twice. Now, each of these sample spaces are representing 1 unit. So head, head, 1 unit, head, tail is 1 unit on its own, tail, tail, 1 unit, tail, head, 1 unit. So total outcome is 4. But we are expecting to arrive at 1. Either we arrive at head, head, or we arrive at head, tail, or we arrive at tail, tail, or tail, head. We just need 1 outcome. So our expected outcome is 1. So you say 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4. LCM is 4. 4 divided by 4 is 1. 1 times 1 is 1. Plus 4 divided by 4 is 1. 1 times 1 is still 1. So on 4 divided by 4 is 4. 1 times 4 divided by 4 is 1. 1 times 1 is 1. 4 divided by 4 is 1. 1 times 1 is 1. 1 plus 1 plus 1 plus 1 will give us 4. 4 ratio 4. 4 divided by 4 is equal to 1. So, the sum of a sample space of any given probability would always be equal to 1. No matter how much the sample space is, the sum of that sample space would always be equal to 1. And the last, which is probability. We've discussed probability already from the beginning. It's still the same thing. The formula for probability is expected outcome ratio total outcome. Alright, that will be all. Thanks for watching. For better understanding, I've left a brief note of what we have discussed with more example at the description space below this video. Thanks for watching. Do not forget to like, drop a comment and subscribe for more. Thank you.